Now let's look at one-sided limits and continuity. You remember we defined the limit from the right as being the limit of the function as x approaches from the right toward the point C. And we write this as a limit as x approaches C from the positive side or from the right. Okay, we can think of this as the positive side. While in contrast, if this is our point C and x is approaching from the left, we can think of this as the negative side. And so this is the limit as x approaches C from the left of f of x. And we say that a limit exists if the left-handed limit and the right-handed limit are equal. So we need these when we're dealing with closed intervals, because let's look at this function right here, the square root of 4 minus x squared. The domain is -2 to +2, inclusive. So it doesn't make any sense to talk about finding the limit as x approaches 2 from the right, because the function simply doesn't exist there. But let's look at the limit as x approaches -2 from the right. We can find that. All right, so as it approaches -2 from the right, we see this limit is 0. Now this function is continuous. Okay, on the closed interval, including -2 and 2, because if I take the limit as x approaches 2 from the left of the square root of 4 minus x squared, that does exist, and it does equal the functional value evaluated at 2. So f of 2 is 0, and here the f of -2 is also 0. So it's continuous on -2 to 2. Let's look at this function, the greatest integer function. The greatest integer function has some interesting characteristics. Here's a graph of it. So let's say I wanted to look at the limit as x approaches 0 of your greatest integer function. So from the left. So from the left, as x gets closer and closer to 0, the limit as x approaches 0 from the left of the greatest integer function is -1. While the limit as x approaches 0 from the right is 0. So the greatest integer function is discontinuous at every integer, or it's discontinuous at 0, and it's also discontinuous at every integer.